Hi, Kelly. Welcome, welcome back. It's time for another episode of Teaching Python, and this is episode 77. Right?
77.
We've
Yes.
been making some progress. So my name's Sean Tiber. I'm a coder who teaches.
And my name's Kelly Schuster Paredes, and I'm a teacher that codes.
Nice. Well, we're trying to sneak in a quick recording today because we've got some things we wanted to talk about and some stuff that we've been working on. So I think it's a good opportunity to just take a few minutes and talk about those things. But before we get into that and all the stuff we've been playing with in the classroom around code reviews and debugging and testing and all those things, let's start with the win of the week. So, Kelly, do you have a win of the week to share?
Well, it hasn't been a win yet, so I'm hoping that it is a win. I guess it's a win on my part, but ear sketch last night, thanks to Russell. I guess maybe it came from Michael Kennedy. I'm not sure. Someone tweeted back in Kennedy, or maybe to get him to talk about it. I'm not sure. We'll have to research that. But ear sketch, wow! I'm so excited for the students that really love music. I tried in 5 minutes of my efforts during soccer practices with my kids to just get in there. And then Russell said something that one of the students did. And it seems so much fun. Word tag, ear sketch.
Yeah, so it's writing code and making music, right?
Yeah, with snippets. So all these really cool, I feel like, what's that one band that was fully animated? In the 2000s.
Like the Gorillas?
Yes. Kind of was feeling like that. I was sitting in my car and I was like, oh, this is cool. What can be the next Gorillaz band or DJ? I thought. And I think it's going to be a good win. I sent it to the student that is not really, she's just been a focus project for me since 6th grade. Every time she gets something, she tries something, she's like, yeah, that was easy. So trying to find something that she will take to the next level. So we'll see.
Nice. Well, for me, the win this week has been doing some things with files for the students. So I always have this kind of weird feeling because we grew up with files and folders and having everything local in your computer, and our students just haven't. Everything's cloud-based, or it's just kind of there, right? Whether it's a Google Doc or Google Drive file or whatever, they don't really think of those as files like you have on your file system. They think of those as just these ephemeral objects in the cloud somewhere. And so it's interesting to me every time we talk about files, I always have to go back further than I think I should have to, right? Like, files and folders. And I'm like, okay, what is a file? What is a folder? Or what's a directory? And so I'm combining this with the command line a little bit. So teaching them some basic commands to get this concept of a file or a path or a working directory or relative path, just enough that they can start to see, like, when they open a file in Python, how to open a file that's in the same folder, or why the file needs to be in the same folder as the program that they're running. And it worked pretty well yesterday. I was very excited to see it. I had the students working on their word list. It was an all Mac environment, and on a Mac there's a file in there under like /user/share/ I think it's like dict or dicts. There's a whole list of words, 235,887. And I know I did this last year, but it just seemed like it went really smoothly this time. I'm not entirely sure why, but just talking through first the importance of files, why we use them, why they'll help us grow beyond what we can type in ourselves, and be able to write our code for things that maybe we haven't already seen or aren't intimately familiar with. So it was pretty cool. We went through and found the longest words out of the list. Of that list, there are 5 24-character words. And we went through different algorithms and techniques for finding the first longest word, the last longest word, and then the list of all the longest words. And you could see that students were getting pretty excited about it because we'd start with, well, here's a list of the first 10 words. What's the longest from that? So we can see exactly whether our algorithm is working properly to find the longest word, and then we grow it to the full list. And so it's kind of neat because you can see that light bulb go off for at least some of them that says, I can go through 235,000 words, but with Python I can do that in a second or two. Like, that's a pretty cool thing.
It is pretty cool. Yeah, it's a great lesson. That's definitely was one that we wanted to keep and repeat. I know we talked a little bit about it last couple episodes, a lot of episodes ago. Goodness, I don't even know how many, but we also introduced a little bit of rewrite in the 7th grade, just test it out to see where it fits. That's the beauty of our curriculum, is that we kind of move it around to see where it goes, and we get to, everyone's a guinea pig. But it's funny, it's starting to feel, and I don't know if it was because of COVID and everyone was online and using Google Drive and working on Chromebooks with 6th graders, but I'm starting to feel a little bit more of a crunch for kids that don't really understand how to use folders or to find things. So I find myself constantly saying, go to the new code folder. Well, where's that? Well, it's in your Finder. What is that? Well, it's here, and here's how you search for it, and these are folders. And students don't really understand that, or here's a file format, I need to get that. Oh, well, what's a PNG? How do you find a PNG on Google? So I'm starting to, I don't know if I never took much notice of it before, but I feel a lot more pains with my 6th graders this year for little things like that. So teaching that file rewrite kind of helps to give them that idea of what's going on in the computer and like that.
Well, the other thing that is easy for us to forget too is that for our 6th graders, this is their first year with like a MacBook or a Windows PC or something like that. So prior to this point, they've had a school-provided Chromebook or a school-provided iPad, which it's not impossible to get to the file system on those devices, but it definitely takes a little bit more effort, or you're not as dependent on it. So some of these students, it's not their fault that they don't know about files and folders. It's not like they've been asleep at the wheel or anything like that.
There are files and folders in Drive, so I'm just saying, and I know they taught that.
Right, but it doesn't transfer. So it's this illusion that they understand how to use their full-fledged traditional computer because they know how to use a Chromebook and they know how to use a web browser and web-based apps, but there's a whole new layer that they're just seeing for the first time by moving to a Windows or a Mac that they may not have seen before. So it's easy for us to forget that because so many of the other things that they can do on their computers, they're very adept at. Yeah. So that part's not quite there yet.
Goes back to that thing where we need more push in ed tech. Those days of ed tech is you just never have enough. Computer science is not built, our computer science course with 9 weeks is not built for full-on ed tech, but listen, don't neglect those ed tech skills with your math teachers, English teachers, social studies, science. It needs to be something that is all over every day inside the curriculum. Pretty interesting.
Yeah, and sorry, I'm just hooking up my light here because it's not charged. Hey, look, it's lighting up. Okay.
Wait, we digress.
But I think that is a good segue into, we're about 6 weeks into the school year now. We've got a lot of new things that we're trying this year and some new approaches that we're experimenting with. So we wanted to cover some of those experiments today. And I think we have kind of 3 major categories of experiments that we've been playing with, mostly around the teaching techniques and the classroom engagement, not necessarily around the tools and the technology. So this is more of a like how to engage your learners sort of conversation. So the first one of the 3, I think we're going to talk about code reviews. We're going to talk about testing strategies and verifying your code and knowing that it works, right? So this whole concept of it runs, but now what, right? And then the third area that I wanted to talk about was the things that you've been doing around, I forget what it is, remind me, it was...
He throws this out there, totally off schedule, not even on the outline.
Well, the main one was the code reviews.
Instances and turtles and classes and all
yeah,
that, so.
I think it was kind of the way that you've been teaching some basic object ideas in Turtle, using Turtle to get this concept of object usage, not necessarily object design, if that makes sense.
Absolutely. Totally threw us off.
Yeah. So for those of you who may not be familiar with code reviews in a professional setting, a code review in a software development team is about working with another developer, typically a senior developer, to review code and use this as a process to improve the quality of the code, ensure that it meets the requirements review it for any sort of issues that may come up, whether that's style issues, logic issues, functionality issues, to ensure that the code that is being produced is the highest quality. And if it's done right, it's a learning experience often for both the junior developer and the senior developer in terms of the way that code is written and the way it's implemented.
Yeah, and in the teacher setting, this is something that's really not a new thing for a teacher. It's one of these basic lessons I think you learn in college, NG 101, where what can you do in order to build a pair programming, pair reviewing, pair doing activity? How can you teach communication skills? How can you have stronger students help the not as strong students in a certain field? How can you help your grading and get better products? And one of the things I always do, especially with essays, is this peer review. Here's a group, here's the things that you need in an essay. Get with a partner. Your partner's going to kind of grade over the essay, talk about it, tell you how to improve, look for grammar issues, and then go back and do your second revision. So I not really enjoy all of the sixth grade first app projects like I normally do, because I pretty much set them free. They're really good coders, but they weren't really good coders at following my rubric as in the past, because in the past I helped them a lot more. So these guys are kind of set free, and then what I got back was a lot of really good ones and a lot of really bad ones. And I didn't want to put a bad grade in there, especially when it was their first app and they were just eager to go. So I walked in the morning and I said, guess what, guys, we're going to do a code review. And you're going to get with 3 people. Everyone's going to have 11 minutes, just 11 minutes. I don't know how to do why, but it was a good number. 11 minutes. We're going to only look at one person's code the entire 11 minutes. If you run out of things, find something else in the 11 minutes. And we're going to look at the things that we need to improve on, look at the basics that we have. And then we're going to switch, and then we're going to switch. And it turned into something beautiful.
So what were the results that you were seeing? Like, what was happening with that code review?
Well, so first of all, it turned into an empowerment. So a couple of kids, there was one student that was completely shy. She submitted, I think, 5 lines of code, and the code was supposed to have certain concepts in there. So we were looking for the use of conditional statements. I was looking for the use of list, and not just put a list in, but some sort of method with the list. I was looking for a string manipulation, basic methods, dot title starts with. Looking for equivalency, checking to see if a condition applied with an input. And I gave them this ballpark of 30 lines. I could care less if it was 30, 15, or 50, but I wanted them to have some sort of goal. And I wanted them to make sure that they understood doctrine or, doctrine through the comments, and when comments should be used and when variables should be used best. Very basic, but those are all the key points of the DT 6th grade. So we kept working with rubric, okay, well, let's start off very basic. And she'd say, you have a list? Oh, yes, there's a list. And I would say, well, are they doing anything with the list? Oh, no. And it would turn into this conversation that was quite beautiful, quite impressive. The kids were like, I don't know what to do with my list. Well, here's what you can do, and they gave some ideas. So that's kind of how it started. And by the second or third round, it was a more in-depth conversation. And then what we did is we asked students if they wanted another review with an expert. And some of the students who felt very confident, who already met the 4 points of rubric, like, I can help you code review. And turned into a really nice environment. I mean, it was such an easy class where I didn't have to ask me for questions. So.
Nice. Well, and I think there's a couple things that I saw as I was observing this was that really worked well. First of all, students use different language than teachers use, right? So when they're giving that feedback or they're giving the information, they often have an easier time explaining it to a fellow student, a peer at the same level, using words and language and structure that makes sense to that student, that learner. So I was noticing that all over the place, like lots of, there's this list thingy or whatever, and they were using imprecise language, but accessible language for the students, which was really important. The other thing too is that sometimes, and it depends a lot on the student, sometimes students feel less pressure when they're having their code reviewed by a teacher and by a peer. Sometimes they feel more pressure, but because there was no grade associated with this, it wasn't like oh, you're doing this for a grade. It was a low pressure environment for them to learn and be receptive to feedback. So there wasn't that same sort of like, oh, my code's on the wall in front of everyone, or the teacher's looking at my code and giving me a grade for it. It was more of like a peer level assessment. And a lot of our kids are really good about giving kind and helpful feedback at the same time. And then the last thing that I saw was that it's always fascinating to watch students explain concepts in their own words, and just the way that they were talking about, things like, what's a conditional statement? Well, you have two choices and one of these can be true and the other one can't be, so it's going to run that code. Okay, well, that's kind of cool the way that they're explaining it, because it's not necessarily the words that I would choose, right? And that's a really beautiful thing.
Yeah. And the added benefit that, and this is one of the reasons why this is done a lot in with essay writing, is you always have those few students that excel in a certain subject, and everyone was able to see that code and see the level that went a little bit higher. And kids were like, oh, I want to do that. That's a really cool idea. Can I do this with my code? And it brought out things like they were sorting through a list. One student had an enumerate on a list that I had showed them because they wanted to count out a list that they had written. And it was just allowing them to extend knowledge based on what they saw from their peers. So I'm totally doing it again, but not doing this without the grade twice. I'm doing it for grading, because I did grade them twice. I gave them the second grade, which was great. Kids were very thankful for that. But this time I'm going to do that with the Turtle app, and where they're doing a mashup with the Turtle, and they're going to code review prior to submission.
Nice.
And then they have another day after the revision to code a little bit more. So it does take a little bit of time. It's 3 class periods, but it's totally worth it.
Well, and I think the comparison is very apt towards like a writing sample review.
Mm-hmm.
I really, the more that I get into teaching computer science, the more I realize that computer science is far more closely related. Its close cousin is writing and language and expression. Like a second cousin is math, right? You can absolutely do math in this, but it's the same way as I can write about math, right? I can use writing to better explain my math, but the real structure here and the real value is that structure of create the code, have the peer review, the code review that happens, and then have the revision and see the progress that the student makes and document that along the way. So it's, what did you start with? What feedback did you get? And then how did you use that to improve your code? Get students a lot closer to what they actually want to have happen with their code.
Yeah. And I saw a comment. It was something that Eric had posted to
Eric Mathis.
Sorry. Yeah. There's like, friends of ours as they're listening to us in the kitchen, just kitchen cleaning. Sorry. Eric Mathis had replied to someone about, do you give positive feedback in code reviews? And that was so funny. I was like, I'm getting stalked in Twitter. These things are coming up at the same time. And that was another thing that came up. I heard positive. Sorry, I was thinking about this while you were talking. Positive feedback. That was always a critical thing that you do during writing peer reviews. I like how you did X. Perhaps you can improve it with Y. I didn't have to set that stage because kids were like, wow, that's really cool. Oh, that's really creative. I like how you did that. Wasn't that a good idea? And it came out naturally because these are first-time coders, so everything's magical for them. But perhaps like next time I might have to remind them, look for the positive in this one and do the positive feedbacks and code reviews. So.
Nice. Well, going from the peer reviews to more of the individual approach, one of the things that I've been working on a lot with my classes, and I know you've been doing this as well in parallel, is going through more of that testing cycle for code and understanding how tests work. So this year we've been focusing a lot more on our code challenges with PyBites. We've written some challenges, some daily challenges, and there's a lot of students who come back and say, well, my code runs, like, why doesn't it pass the test? Or why doesn't it say that it's correct? Well, it's the same thing as saying, but you can print hello world in there and it's valid code and it runs, but it doesn't do what it's supposed to do. And what's fascinating to me about this is that this is where you really see the attention to detail come out, right? You have that first layer of attention to detail, which is are all my indentation in the right spaces? Am I using the same variable names? Do I have name errors because I have typos? Like all of those things come up as part of the first level of attention to detail. But the second level of attention to detail is definitely more thoughtful. And it's that idea of examining what am I expecting to have happen? Like what's the expected output of this code or the expected functional performance of it? What is it actually doing? And then what's the gap in between? And when we put this in a couple different contexts, the first context is when we're doing a code challenge or something where there's a prescribed output that they have to match. It's one output. How they get there is up to them, but it's the one output that they have to match. What are they intended to do? That's defined by someone else. What is it actually doing? They have to look at that and see the output and the comparison. And that works really well for them to write to a spec. The second one that's probably harder to define and far more interesting to me is when they write their own code and there's the gap between what they have in their mind as their intent and what it's actually doing, right? This idea of, I expect it to be doing this, but it's doing this completely different thing instead. Why is that happening, right? And I think what's our common refrain these days, like, it's not working. What's not working, right?
Yeah. Guy walks into the doctor's office. It hurts. Great, thanks.
Right.
That's my common response.
We can't really help you with that. So I find it fascinating as we go through this process that a lot of what we're doing is trying to unpack what they're saying and trying to get them to think more clearly, more specifically about what's happening, what's not happening, and why there's a gap between the intent and the outcome. It's a really, I think this is like most of programming in a nutshell, right? Is this process of closing that gap and getting it to work the way you want it to.
Yeah, and that's been a huge learning curve for me. Both of the courses that I'm taking right now are going through tests. I actually tweeted to or messaged Brian Onken, and I was like, I'm finally getting into tests. Being able and actually, reflecting on my learning, having someone say, write a conditional statement, and I do this to sixth grade, just write a conditional statement. And what do you want? I don't care. You're creative, do that. Well, that's kind of easy. It's an easy thing to accomplish. I don't have a set goal. I don't have a set outcome. Write a conditional statement that allows them to have options. But when I start saying something more specific, that if it's this, I want it to output exactly that, then that takes it to a different level. And I think we're starting to implement that more in seventh grade, because with our code challenges, we would give them these simple challenges, but not having a way for them to test if it's right or if it's coming out with what is expected was something I think we're missing. We've always had the platform where we could develop that, but we haven't gotten to that yet.
Yeah. Well, and now it's creating this other fantastic problem to have, which is that the students are realizing, well, wait, if there's 4 tests and it looks for these 4 outputs, can't I just make it so that if the input is this, then produce that output directly without doing any of the work in between, right? So I've had a number of students that have I've outsmarted Mr. Tiber. I'm writing the code so that it'll pass the tests, but then what I'll do is I'll sneak in some other tests that will have more random inputs, so here's an input of randomly selected numbers, and I know what the expected output should be, and it changes every time they run the code. So we did that with a list of numbers, sum all the even numbers in this list, where we generated a random list of numbers, and in my test it calculated the expected result that I could verify and compared that against their answer.
Yeah, funny story, because I had the same thing happen. I gave them the test of, it was the simple function here, hour to seconds, and the test said a 2 and 4.75. And it was funny. A lot of my kids still, trying to get through functions, they don't want to put those parameters or anything in there. They want to put input. They're not using the function as stated, as intended. And then even better was the beauty where they said hours equals 2, hours equals 4.75. And they're like, but I got what you got. I'm like, okay, well, hours equals 3, but you didn't tell me that. And I'm like,
Right.
but it was intended to convert any set of hours.
Right.
That's what the program was. So they are pretty cheeky and pretty smart. So it is a good thing to talk about how tests can help them see solutions. It goes back to that book that we were reading about. We have the grain and the
Oh yeah, the logical problem solving.
yeah. So we give it, but when we give them the answers or we give them how we want the solution, then they can start seeing ways of solving the problems. And I kind of feel that's the way with tests. When we give them what the outcome should be, they can start seeing I have to start and finish what needs to go in between. And it makes that thinking process just change a little bit. I know it has for me, because I definitely always now know how to look to the test in my PyBites or in my other courses, because I'm like, oh, that's what it needs. So how do I get that? And I can work backwards.
Right.
Backwards.
So we wouldn't have that moment though of the you need to solve for the general case, right? We wouldn't have that if it wasn't for having the tests, because when they see that, oh, I could solve it for these 3 different inputs, all I have to do is produce these 3 outputs. It doesn't actually have to solve it for any other output. We get to have that conversation that says, but that's not really the point, right? That's the point of this is to write code that works for the whole domain of inputs, and come up with this range of outputs that are correct. And how do you know that it's correct?
It also helps to highlight how crummy some of our class challenges are written. And I'm like, oh, okay, you got me at 4.25.
Yep.
I wrote that poorly, sorry.
Yep.
And that's the beauty. Sometimes I'm up there and I'm like, okay, class challenge today. Well, what is it? I'm like, hold on, it's coming in my brain. Yeah, this one. So it's a good thing.
Yeah, and I think it kind of leads into the third area, and this is something that I wanted to talk about was around this idea of how students go from that I know a few different patterns to now I can start to generalize, right? I can start to assemble these patterns that I know into larger patterns and larger solutions. And I think we start to see it in 7th grade. I mean, you can see it in its rawest form in 6th grade, but starting in 7th grade and 8th grade, that's where I think it really starts to take off, and getting students to go beyond that. I know an answer to this problem, I know one way to do it, into, well, here's some interesting ways to solve this, right? And that's where also having those really large data sets or the really large inputs or the randomized tests or the things that they can't predict ahead of time really goes a long way.
Absolutely. Absolutely. I was going to say something, but we're short on time. If you want to go to teaching basics, because I was going to tell another story, but it can wait till next time.
Well, I mean, so the last thing that I've been experimenting with this year is really starting to get out of this idea of here's the IDE that you have to use, here's the Colab or the Mu or whatever, into you can write wherever you're comfortable, right? And so now we start to get into what are some of the advantages of different environments to code in, different ways to set it up. What do you personally feel comfortable with? So I've got some students who are very comfortable using Mu Editor, right? I have students who are like, no, give me the VS Code and the command line and how do we make this work? And what's really interesting about this is now we're starting to get them to turn into, to have preferences for their coding, to have, like, when they think about, I'm going to write some code, I'm going to go to this spot and I'm going to write it and I'm going to figure it out. And I think this is kind of like the last step in our middle school process of getting them to become comfortable with coding, is when they start to express preferences and opinions about why they like to code in the environment that they do, why they're choosing to use this for loop instead of a while loop, or instead of writing the code one after another, right? We start to see that there's this, they're settling into this comfortable territory of, I can write code and I can use it to solve problems. Even though it may not be that it's their first choice or their first method is to write code for it, we're starting to see them want to write code and want to have preferences. And I think that that's a pretty cool sign that we're starting to see this year with our 8th graders, more broadly than in the past.
Yeah, in 7th grade, I'm getting it. I have some really, I mean, they're out coding me already. I'll be honest. There's some kids that are just the way that their brain works is so beautiful. So allowing on the same idea of teaching basics, but allowing them this agency kind of thing with their own code editor. We allow that in seventh grade. We do use more of the CoLab environment just because it's easier on us and we can give out our choice words. But I have this one student, and it's funny, we were learning the datetime module, and I just wanted him to learn how to use this module, read this documentation, very simple, going through a couple of apps. It was teaching functions and how we can make code shorter. And he says, I don't want to use a datetime module. I want to calculate by myself. I'm like, go ahead. That should be fun. And we were calculating dates. And he wanted to calculate your sign with your date of birth, with the number of birthdays. The kid worked through it. It was basics. It was going through the basics of code, but the way that he was thinking, and he did do a dictionary, and he looked up the values, and then he added the values, and he subtracted something with something else. And I was like, cool. You don't know the daytime, but I'm sure you can figure out. He's like, I'm writing the next daytime.
I love that. And he came to me and he's like, I'm trying to figure out how to get the number of weeks it's been so far since or how many weeks it is until your next birthday, and then the number of days. I'm like, have you thought about DivMod? And he's like, wait, what's that? So I explained to him, like, you can get the dividend and the remainder when you divide two numbers using this DivMod function. And he just, like, his eyes got big and they lit up, and he's like, I'll be right back. He runs over and he starts coding away on it. It was so much fun to see.
His brain, like, it just starts ticking. So him and this other student who I got into PyCharm and is taking one of the courses that I'm taking, and I called the friend up and I was like, listen, I've been stuck on this and I won't ask Mr. Tiber for help, but I just want to see what you do. Gave it to him. He comes back with the solution. I was like, well, that one doesn't work, but this is what I did. He's like, oh, I see what you did there. Kind of like that. And I was like, wait for it. Let me show you what this other guy did with a list within a list comprehension with something. He goes, what? Wait. Oh. And it was just like this beautiful thing. So those two kids are pairing together on a project, going back to basics again, allowing this agency. I gave them a choice. Who do you want to pair with? They're going to do the card game. And I said, listen, I have this card game that I've been working on for about 3 years. It's never been finished. It's got like 5 different games in there, all started. And it's got tons of errors. And I'm sure the variables are crap too, because it's been over the past 3 years. Can we use that? I'm like, have fun. We're going to use it. They're like, we're going to finish your app for you. I'm like, thank gosh. Can you finish my database for me too? Because, I need that.
We're going to outsource our coding to all our 6th and 7th graders.
All our 6th and 7th graders.
Well, with about 3 to 4 weeks left in the quarter, what are your plans? What are you going to focus on for the last 3 to 4 weeks?
Oh my gosh, we're doing the beautiful hardware, which, it's a love-hate thing. So, but we're bringing back soldering finally. We get to get back into soldering, talking about the beauty of soldering and how we can use that to prototype. We might not get into any of the actual products, but we're gonna look at it, and we're bringing in microbits back in 6th grade, obviously, and 7th grade we're using Circuit Playground.
Nice, and there's the bell, actually. But for me, I think the last 3 to 4 weeks, I know that our students that are on top of things and really excited about it have been leaning forward in their seats the whole time, are moving, and I'm going to keep up that momentum. But really, my goal now for the last 3 weeks is to get as many of the rest of the students to have that aha moment where things click and it starts just making sense to them, and they're just writing code and making it work. And so I think it's going to be a lot more examples and practice and try these things. And I'm going to bring in EarSketch, and we're going to play around with these things and hopefully get kids to have that moment where they lean forward in their seat and go, oh, I get it, or it clicks, or I can write some code now. I have been noticing, and I think this is a little bit of a getting back into the school year as well as me getting back into the teaching realm. I don't have as many students who are just having things start to click. If I ask them to write code on their own, they're lagging behind what they can read, right? So their level of understanding code when they read it is still way ahead of what they can write on their own and how to compose it. So we're doing some things like I just had each student type out the entirety of the Bagels game code from Al Sweigert's Big Book of Small Python Projects. And I told them, I want you to write everything. I want you to write the comments. I want you to write the indentation. I want you to do every single bit of this code because I want it to match line for line, character for character, and you can't copy and paste it. I said, this is the equivalent of, copying something down to get the practice of the feel of it, the way it sits together. And it's like riding a bicycle through your neighborhood instead of driving through.
Yeah,
right?
but he doesn't tell you that he left then and then made me deal with all their issues. I'm like, indentation, name error. You didn't do that. Go figure it out.
Because it's not copied, right?
Yeah,
They didn't copy it correctly.
They had so many errors, and I was like, this is not Miss Freida's code debug. This is go debug your own. But it was beautiful.
You get what you
You
practice,
get what
right?
you practice. Absolutely. Write more.
Right. So I'm gonna have them just writing code the last few weeks, writing code, whether it's their own code, they're writing other people's code. As long as they don't copy and paste it, I want them to get that muscle memory of I'm writing Python code, I'm writing Python code.
The myelin wrapped around the nerve.
Exactly,
memory.
right? Exactly. So that's my plan. I know we're running a little bit short on time now because you have a meeting to get to, and I have kids coming soon and everything. So, just to wrap up, we have our guest schedule coming up for the remainder of this month. We have some good guests planned, and we have some robots coming in and all kinds of fun stuff for the next few weeks of teaching Python. We're going to try to get back on our weekly schedule now and the cadence of recording and publishing every week because now we've gotten through that initial start of school and things are starting to smooth out in terms of our pacing and everything. So
we're going to be skinnier because of that. So just remember, we're not eating lunch because we're recording with you.
That's good. It's a double benefit, right?
Double benefit.
So it's here. So if you want to follow up with us, we'd love to hear what you're doing right now, what you're finding with this new school year, things that are working really well, things that maybe need a little bit of help. You can always reach out to us through our website at teachingpython.fm. We also are on Twitter at teachingpython. I'm at smtiber on Twitter. And Kelly is at Kelly Pered on Twitter, and that's where we kind of live on social media. And I think there's no other real announcements this week. So for Teaching Python, this is Sean.
And this is Kelly signing off.